Okay, so optimization. Start of new unit. Unit 6, optimization. I think I can say that there are no new derivatives to learn. It'll just be applying the derivatives that we hopefully already know in a slightly different, a different spot. And optimization is definitely where there are real-world uses of calculus, and we'll see that in a minute. And some of these are like contrived and simple, but I don't think it's too hard to see how you could extend it further and like legitimately use some of this stuff in a business sense. You want to maximize profit, you want to minimize waste, you want to maximize some things and minimize some other things. That's what optimization is. In fact, maximize the good stuff, minimize the bad stuff. Very technical terms. So we'll maximize profit and area and volume, that kind of thing. And we'll minimize cost and basically things related to cost, materials, that kind of stuff. And obviously we'll use calculus to do it. In the previous unit we analyzed functions, so we didn't really have a word problem attached to them, they were just equations. In this unit we will kind of do the same thing, except there will be situations, word problems. The first section is called optimization. We might be asked to maximize profits, or we might be asked to minimize cost. So let's start with a simple one that doesn't really have a real-world application, but it's simple enough that we can learn the process and then extend that a little further. Find two positive numbers. Okay, so let's start labeling things already. Two positive numbers. So let's just call those x and y, because we don't know those. That's what we're looking for. Find x and find y. Such that the sum, what does sum mean? Add. Twice the first and 3 times the second is 150. So that's going to lead to an equation. So not maximizing off that equation. That's just a straightforward twice the first, 3 times the second. So twice the first plus 3 times the second is 150. And their product is a maximum. Okay, so some steps. And these are steps that we want to understand. Obviously, you're not going to memorize these paragraphs that go with these steps here. But step one, ask yourself what is being maximized or minimized, and write the equation for this. You may or may not be given this equation, kind of depends on the problem. So for this one, I guess we'd say what is being maximized or minimized. That's the main thing for step one. Like, well, what am I trying to maximize here? And this one says their product is a maximum. So their product, that would be multiplication, is xy. And that's what we want to maximize. And whatever you want to maximize is called the primary equation. You're not going to have to know what they're called. It's an easy way to refer to. Usually we'll have two different equations. One's the primary, one's the secondary, sort of the helper equation. Again, you don't have to know those, you're not going to have to label those, but just so that we can talk about them, you need to know what I'm talking about when I say primary equation versus secondary equation. So, step one, figure out what we are trying to maximize. Step two, if the equation you wrote is in terms of more than one variable, as in x and y, write it in terms of only one independent variable, if possible. It's usually possible. This usually involves using other information given in the problem. So I'm going to take my secondary equation, like the sort of the helper equation, and use that. So let's see. I want to get rid of x or y. It doesn't really matter which one I do. Do you have a preference? Do you want to solve for x or solve for y? X it is. So 2x equals 150 minus 3y. X equals 75 minus 3 halves y. Okay, so now we'll substitute that 75 minus 3 halves y in for x. So P equals 75 minus 3 halves y times y. Okay, let's go ahead and distribute. I think that would be a better way to go here. So product is 75y minus 3 halves y squared. All right, so that's step 2. Get an equation of one variable. Talk about it. So I took my primary equation up here. I replaced x with all of this, and that y was still there, and then I distributed the y. So one independent variable, one variable. Step 3, analyze the equation or situation. And that's kind of a all-encompassing word there, but some questions to think about. Can you tell if it does indeed have a min or a max? Which are you trying to find? Does the min or max occur at a relative extrema versus an endpoint? And so you just have to think a little bit. What shape is this thing? 75y minus 3 halves y squared. Yep, most of you are doing a parabola, but an upside down parabola, because the negative y squared. So sometimes, not always, and maybe not even often, but sometimes you can get a feel for what the thing looks like. And if that's the case, and we know we're looking for a maximum, it's like, oh, well, that would be the maximum right there. So this thing does have a max. I can probably find the max. All right, now here's where the connection comes in with what we were doing last test, and that is use a calculus word and tell me what's happening at maxes and mins. Zero slope, so f prime equals 0, or I guess in this case p prime equals 0. Step 4, find the critical values of your equation. So f prime equals 0 or f prime undefined. So I want to find those potential maxes and mins by taking a derivative. So p prime 75 minus 3y. Because we're taking a derivative with respect to y. This is a little bit weird. We usually take it with respect to x. But you guys solved and got rid of the x, so we're taking it with respect to y. Set that equal to 0. So we move things around. Oh, let's read a little bit here. Take the derivative, set it equal to 0. We did that. If you're not sure if your critical number is a max or min, then you do the sign chart thing, where you can do, increasing, decreasing, to figure out who's a max and who's a min. Thank you. But this one I don't have to worry about because I already know it's a parabola, so it only has one critical point, and that's a maximum. So I don't really have to think through the increasing, decreasing stuff. I can just solve this for y. Y equals 25. Again, this is a simple one. Most of the time, you're going to have to put it on a number line and figure out where the derivative is positive and negative, so you can figure out if it's a if it's a max or a min. And then my favorite part, please make sure you answer the question that's being asked. Okay, that's not so bad on this one, but a lot of times you get this long word problem. Students do all the calculus right. They've got x equals 7, and the question was, what's the profit? And I'm like, well, you got to answer the question. So make sure you go back and figure out exactly what are we looking for here. Find two positive numbers, x and y. Okay, so y equals 25, that's one of them. How am I going to figure out the other one? Plug it back in somewhere. Yeah, I would plug it into the x equals thing. That would make the most sense. We take that x equals equation. X equals 75 minus 3/2 times 25. That's a safe stop, so I guess you could just stop there and leave it. 75 minus 75/2. Again, maybe wisest to safe stop that and don't risk messing up our fractions. That'd be 150/2 minus 75/2 is 75/2. But yeah, safe stops are still available here, so make use of that. It doesn't have to be a complete sentence, but make sure I know what you're talking about. The two numbers are 25 and 75/2. I don't want to write it like an ordered pair. 25 and 75/2. Again, make sure you answer the question. Obviously, you're not going to lose a whole bunch of points if that's the only thing you miss, but it's a bummer to get all the hard stuff right and then miss a couple points just because you didn't fully answer the question. Okay, so it's just using what we already know about finding maxes and mins, except now our maxes and mins are on word problems. Like Brooke was saying earlier, it didn't seem that hard because we've kind of already done it. And that's a fair statement. Number 2. A ball is thrown straight up from the height of 3 feet. Its height after 3 seconds, or after t seconds, is given by this equation, where s is in feet. What is its maximum height? Okay, so I'm looking for maximum height. Here's what you need out. This tells me the height. What type of equation is this? Like, what is that graph going to look like? A t squared in there. I think this is another downward parabola. So there's a max somewhere, and that's what I'm looking for. So let's find S prime. That would be negative 32t plus 20. We'll set that equal to 0 because at the max, S prime is 0. So let's see, t would be 20 over 32. That's a safe stop. You can just leave that. Although that's not hard to reduce. 5/8. So at 5/8 of a second, we're at our maximum. That's our time. Haven't done anything wrong. Is that the answer to the question?
Oh, no.
No, it's negative 20 over negative 32. I guess you could say it that way. But the question is, what's the maximum height? So what do I need to do to find the maximum height?
Plug it in.
Plug it in. Into S or S prime? S. What will I get if I plugged it into S prime? I would get 0. which I kind of already know. So hopefully if you plugged it into S prime, you'd realize, wait a minute, something's not right here. The height is the S. So S of 5/8. Definitely a safe stop coming here. So there's our maximum height. Again, make sure you answer the right question. A lot of these are going to be calculator problems, because if you're working a word problem, you don't want to know that the maximum height is that weird expression. You want to know what the height is. All right, let's try one more, and then we will be done. Number 3. A rancher needs to make an enclosure for his herd. The enclosure will have 2 areas sharing one side, as shown in the figure below. The rancher has 500 feet of fencing to use. What dimensions, values of x and y in the figure, will produce the maximum enclosed area? So let's write our equation we want to maximize first. So what's the area based on x and y? Yeah, just x, y. That's what I want to maximize. But that's got 2 variables in there, so I would really like it if there was some helper equation, some secondary equation that I could use and get rid of one of those variables. Well, what is this 500 feet of fencing? Yeah, it's how much fence he has. And we're just going to assume he wants to use all of the fence to get the maximum area. So how much, what's going to add up to 500? 2 x's and 3 y's. He's got to mark off, because he has that middle thing in there because he needs, 2 different sections for whatever reason. So 2x plus 3y equals 500. Okay, so this is really similar to that first problem we did. 2x plus 3y even is there. You want to solve for x or for y?
X.
Why x? I think I agree with you.
Because eventually you'll have something squared and
Okay, eventually we're going to have something squared. That's going to happen either way.
when you have the derivative, you cancel out the half because the 2.
I think it's easier just because I'd rather divide by 2 than by 3.
Yeah.
It's not going to really matter, but it seems like it'd be easier to divide by 2 than by 3. So 500 minus 3y equals 2x. So 250 minus 3 halves y equals x. Again, it would have worked either way, but I'd rather 250 than 500 thirds. So area now is, I'm going to substitute for x, all of that stuff. 250 minus 3 halves y times y. So 250y minus 3 halves y squared. Oh, and this is what Brooke was mentioning about the y squared derivative is going to be easier too, rather than having the thirds to deal with. So let's take a derivative of a, because I know this is a parabola, I know it's a downward parabola, so I know we're headed for a max here. So a prime is 250 minus 3y. So we're still going to have to divide by 3 here, but that's okay. Set that equal to 0. 250 over 3. Again, if you're the actual rancher who needs to, build this field, you don't want to get 250 over 3. You want to figure out what that is. The 83 and a third, I think. I'm not boxing that up. I'm going with 250 over 3 in case my fractions are messed up. So that's right, but have I answered the question yet? What dimensions, x and y? Okay, I got y, so I'm almost there. X equals 250 minus 3 halves times 250 over 3. Oh, that was convenient, leaving it as 250 over 3. Made this work out quite nicely. 250 minus 125 equals 125. So x is 125 feet, y is, I'm just going to leave it as the fraction, 250 over 3 feet. And that combination of things would give us the maximum area. And we didn't do this, but if you have lots of time, you can challenge students to do this before they know calculus. And so some students will build a pin that looks like that. And you're like, well, that wouldn't have very much area. Or you could build it the other way, where it's like this. Well, that doesn't have much area either. So you got to find that spot in the middle that maximizes the area. Okay, we'll stop there. And we'll say worksheet 1. I mean, eventually we're going to have to do all of it. Let's say 1 through 6. 6 whole problems for homework.